This beautiful structure is called a fractal tree. Although this looks complex, but this is very simple. So let's get started. First, I have created a blank file called f-tree, and before we start, let's open command prompt in the folder which your file exists and check if you have installed a pygame. Type python 3-m pip install pygame and hit enter. After that, you're good to go. Now I have opened this file in Sublime Text. First, you have to import pygame, and from pygame.draw import line. Then you have to use some helper function from standard library of math like sine, cosine, and radians. Then you have to initialize pygame. Just type pygame in it. And now this is our height and width of our main window screen. Now these are some color constants. Black is 0, 0, 0 and white is 255 to 255, 255. Now this is our main window. We, as a convention, we write it as a variable name surface. Make sure you put first variable width and second variable height, as pygame takes x-axis first then y-axis. Now to create a variable called run and create a while loop. This will be our main event loop in which all our window will refresh. First fill window with black color and then update window. You don't have to remember any of this stuff, just copy and paste this. Now this stuff will be useful to cancelling our window. As a default, pygame cancel button don't work, so you have to write this code for event in pygame.event.get. If event.type exactly equal to pygame.quit, run equal to false. Making run variable false will exit us out from the while loop. And now save this code. Go to your command prompt, sec cmd, and run python f-tree. Now as you can see, our blank window is created. Now we are ready to code. First I am creating a function called f-tree, and let's call this function from our main loop. So each time our loop runs, this function get called. Now just for starters, let's draw a line. Now line in pygames take first argument as a surface. This will be our main screen as you define here. And now second argument is as a color. I'm just putting white. Third argument would be first position, and then our second position. Let's put first position as 100, 100, and let's put second position as let's 500, 500. Go ahead and run our script, and as you can see, line is drawn. Now what we have to do is draw a line from down here to the up until the somewhere middle. So what I can do is make a initial position init underscore pos equal to width divided by 2 and height. Pass this initial position as argument, receive as argument, and now replace our initial position with pos, and again this has to have to be pos. Okay, our line starting from here, but we have to create complete perpendicular line to our window. So what can we do is we can take second argument length okay, and let's pass initial length as 200. Let's get rid of this stuff. Our new x let's unpack our position. x comma y equal to pos new underscore x equal to now this will be our sine of some angles. Let's take 90 times length, and again same cos new y equal to cos 90 times length. Let's run this. Okay, we got error. Okay, we have to pass argument new x comma new y. Now let's run this. Okay, we have drawn line, but have gone little out of control. So what our main problem is, this new and x and new y is position are with respect to origin. We have to translate them back to the our x and y. So x plus and y minus. We have to write minus because in pygame y increases as we go down, not not like our traditional graphs where y increases we go up. So let's go ahead and let me just clear this window. Let's okay. Now we have again got an error. Okay, we have to pass an integers, we have passed a float. So what happened is we have created this function, but this returns floats, but pygame can't draw floats. So let's quickly convert this into integers. Let's go ahead and run, and we are still not seeing anything. Now why that must be? Okay, so our x coordinate has to be cos and y coordinate has to be sine. As we go as unit on unit circle, cos is respect to the x direction and sine y is respect to the sine direction. Actually sine is respect to the y direction. Let's run it again. Oh, and we are getting line slightly tilted. Okay, let's check again. Why this mark? Okay, I just figured out the problem. This sine and cosine functions from a math library don't take degrees as argument, they take radians. So I have to quickly convert them into radians. Now let's go ahead and run it. Hopefully this time it will work. And we have vertical line. Okay, uh, let's pass this angle as our argument. Angle. Angle. Let's create angle here, 90, and angle. I will explain why we are creating this in just a little bit. Okay, so let's pass another argument as a depth. We have to know how deep our tree should be. Let's pass here, I suppose, 2. Take depth as argument 2. And this will be recursive function. That's why we are passing this argument depth. If depth exactly equal to 0, return. Okay, now what we can do is we can call this function recursively. So, and this is the best part of this program. Just copy the function increase angle by some random degrees. I'm choosing 30. For second call, decrease it by 30 degrees, and this will be our node position. So new underscore position equal to x comma new y. Okay, and we have to decrement depth. So depth -1, depth -1. Now let's run it, and we have two branches. Now just increase the depth and you will get your fractal tree. Okay, so what's happening is a length of our each branch is same as original, so we have to decrease its length, and I'm decreasing length by some number that is totally unrelated, 0.69 times length. Let's run it. Hopefully now, as you can see, we have got our fractal tree. Now let's make it move. In our main event loop, increase angle by some degree. I'm using 1. Oh, okay. We cannot move with this angle directly, so okay, I figured out it. So what we can do, we can leave this angle as a constant. I'm putting 90, and we can pass another argument as angle, and more specifically this will be our turn angle. So change this variable turn angle, and this will be our turn angle. Now what you can do is receive this argument turn angle, and now when we have to change angle, rather than changing it by some arbitrary amount, we can change it by turn angle. Now if you run it, hopefully it got an error, missing positional argument depth. We've taken the depth, missing positional depth on line 27. Okay, we have to pass turn angle too. We are just changing angle, and now as you can see, our fractal tree is working. Now let's color it, and I'm changing speed just to make it little slow. Now what we can do is we can pass another argument as color. I'm passing defaultly white. We can receive this color, and first argument true, and receive this as a split. So let's make color arguments. Color 1 equal to color 2 equal to color, and a split color. Okay, so color 1 will be blue, and color 2 will be red, and we have to also pass these arguments. Color 1, color 2, and now if we run it, this will be not quite as we expected. So it's not coloring, but why? It's split. We are passing split as true. We are receiving split. Okay. If you forget to add color to our line, change default color to the color. And now if we run it, okay, our fractal tree is colored, but not as we expected. On each split, this fractal tree is coloring branch with different color. Now what we have to do is break and pass split as false. So only first time our tree will we get color. As you can see, our fractal tree is done. This is a very simple but very beautiful code.